Perfect. Thank you guys for joining our next session, which is your next power server is just around the corner. For storage, you have options. So we have Richie Palma here from Service Express. He's an IBM infrastructure sales consultant. If you have questions throughout the session, you can put them in the Q&A tab on the right. Any questions that we don't get to during this session, we will bring up in the live Q&A at the end of the day tomorrow. If you have any other comments, you can put them in the chat function. And with that, I will hand it off to Richie.
Thanks, Brooke. All right, welcome everybody. Let's just dive right in because this is typically an hour-long session, so ended up having to dial it back a little bit, but we'll jump in. So this is your next power server. It's just around the corner. For storage, you have options. Brooke kind of gave me a brief introduction. We won't waste too much time on this, but I've been in the space for quite a long time. IBM champion for power systems, and really have fallen in love with IBM Power and IBM's external storage. So when we look at IBM I in the SAN hardware stack, we have this great OS, greatest OS on the planet, which is IBM I. Then we have power systems. So they're the most powerful servers on the planet. Continue to drive innovation within the power systems brand, faster, more efficient machines. And then we have this amazing and robust storage platform that IBM's really done a great job putting together they've always done a good job, but really started, creating a consolidated, robust portfolio within the last 5 to 7 years. So when we look at external storage with IBM I, we typically, a lot of IBM I shops or some smaller IBM I shops, they will run internal storage where IBM I manages and handles all the actual storage or actual disk under the covers. And when we bring in IBM external storage, we basically are taking the storage layer and we're separating that from the actual compute layer at the power system and the OS layer. So with that, you have the SAN control enclosure, which is the appliance that's going to house drives. So you'll see in this presentation, there are not just the old SSD and spinning disk drive options anymore. There's some amazing technology just in the disk units itself. And then you have this great storage software package that IBM's really developed and consolidated across all their different storage platforms. So we look at IBM's storage portfolio. This is the whole portfolio, which goes from kind of the entry-level 5015 all the way to DS8K, 9500. Most of my IBM I customers live in this world. So, anywhere from kind of the 5015 to the 7600. And we'll talk through some of the things that you get as you move up the chain here. So if you look on this entry-level model, it's still very much a SaaS-based unit. Most of our customers at least get into the 5045, and then you get into the 5600, and you'll see some additional technologies that get introduced, and we'll talk about those in a little bit more detail very shortly. But you're getting into flash core modules, policy-based replication, policy-based HA. So a lot of advanced functionality kind of in this threshold here. So one of the coolest technologies I've seen introduced over the last five plus years within the storage portfolio is flash core modules. So flash core modules are essentially NVMe storage. So NVMe is kind of the go-to storage across internal storage and external storage. It runs on NAND flash. But what the IBM's proprietary flash core modules do is they took the flash technology that would be in any NVMe drive, and they added some features and functionality inside the modules itself to be able to do things like on module compression, on module deduplication. So with a typical SSD or NVMe based drive, you'll have a much smaller controller on the drive. You won't have any of the much faster memory and the caching that's on these individual FlashCore modules. So as of I think it was late last year, we were introduced with these 5th generation FlashCore modules. Previously, the raw capacity on these drives was in increments of 4.8, the 9.6 with fifth generation FlashCore modules. The raw capacity was increased significantly. Also built in some technology, so it's going to give you much better data reduction. So we look at, as we compare FlashCore Module 5's FCM 4s, the actual module itself changed physically. So it's taller, longer, thinner form factors. So we can actually put more of them in certain units. Increased capacity without an increase in appliance footprint. When we look at the data center, rack density is critical in today's world. You want to pack in as much data into as few rack users as you can, and then if you can do that while still maintaining performance, that can have a huge impact as we scale data centers. And then there's a 20% more raw capacity increase for each drive. And then in the past, IBM had estimated 3-to-1 compression ratio. With these FCM5, it's 6-to-1. So here's kind of a peek at what they look like. You can see the form factors change significantly. So the FCM5s, it's a lot more packed on each individual card. That's where we get the performance and the additional capacity. And you'll see they're also thinner. So for example, with the 7600, which was just released, we can put in 32 of these FCM5 modules, where the previous 7300, we could just do 24. Can we look at compression within external storage? There's a few ways we can do it. So on the lower end machines, we can do SAN controller compression. So we're letting the SAN itself do the compression for your data. So it consumes some compute to accomplish it. You can do that compression over standard hard drives or SSDs and NVMe's. Then with the FlashCore modules that we just talked about, all that work is done on the FlashCore module itself. So there's zero performance degradation to the SAN storage controller itself, which is a massive benefit. One of the things that I don't have a slide on because I had to carve it out with this, previously being a hour-long presentation, but we can also do deduplication, and then we can encrypt anything that goes on the FlashCore modules. The encryption piece is a huge benefit to IBMI because we haven't always been the best at encrypting storage at rest, especially on operating systems before 7.6. Another really cool feature about IBM SAN storage is called distributed RAID. We'll touch on this quickly. With traditional RAID, you're dedicating drives in the RAID set to RAID and hot spare. With distributed RAID, we're distributing those RAID and hot spare drives across all of the individual FlashCore modules themselves. So this does a couple things. One, which is extremely important, is rebuild time. So when you have to rebuild one of those FlashCore modules onto one of the drives, you're looking at 5 to 10x faster rebuild times compared to traditional RAID. Because traditional RAID, you're having to write all that data to one drive. With distributed RAID, you're distributing that across all the drives. The other huge thing for IBMI shops is it's related to RAID expansion. So with internal storage, if you wanted to add additional storage on a machine or in an expansion drawer, you would have to add a whole new RAID set. So if you needed 300, or yes, we'll call it 300 more gig of space, you would end up having to add the 300 gig plus like 3 or 4 more drives to get a complete RAID set with hot spare. So with distributed RAID, we add a drive under the covers, it goes through and it balances things, adds it into the RAID set, and you're going to get the equivalent of whatever that drive is minus the protection capacity that needs to be on that individual drive. So huge improvement in the ability to scale these machines. Thin provisioning. So basically thin provisioning on SAN storage is virtual storage allocations instead of hard allocations. So you're basically tricking the environment of thinking it has more storage than it physically has. This is a kind of an example. They say a picture worth 1,000 words. This is an example of what typical hard storage allocation would look like. So in this environment, you have 6 LPARs. So LPAR 1, we're allocating. So we're hard allocating 6.5 terabytes to that environment. That environment's only consuming 3.6. So you have 2.9 terabytes that are just sitting there, not doing anything, just waiting for that environment to grow. Same thing with environment 2. Hard allocating 4.8 terabytes. We're only consuming 3.3. So you have 1.4 terabytes that's just sitting there as open capacity. So when we look at thin provision storage environment, instead of hard allocating the storage, we're telling each one of these environments so environment 1, we're telling it has 6.5 terabytes of storage. It's only consuming 3.6 terabytes of storage. So the SAN storage itself is only allocating that 3.6 terabyte. Same with environment 2, it's only consuming 3.3. We're tricking it into thinking as 4.8. And so anytime that environment needs to use additional storage, it's going to go out and get it from this pool. So this unused storage pool. What's nice about that is you can, if you have a lot of environments, you can greatly reduce the total amount of extra storage you need in the machine, with an understanding that you just have to have this as a shock absorber. So when those environments need it, it has the ability to go. You definitely would never want that unused storage that's sitting in the thin provision environment to ever go to 0, because it would be an ugly day. Another major advancement that we've seen in external storage is called policy-based replication. So previously, with storage-based replication or SAN to SAN replication, you would have to configure a certain amount of LUNs on the source machine. You would have to configure those same amount of LUNs on the target machine. You'd have to create the relationships between each of those LUNs. If you wanted to increase the capacity in those environments, you'd have to go in and do a bunch of work to make sure the LUNs were created, close to the same time, and that everything was in sync. With policy-based replication, IBM did a basically ground up rewrite of the way SAN storage replicates, and it allowed you to, instead of creating LUNs and mirroring them, you're assigning a policy for replication. And because the source SAN and the target SAN have a relationship with each other, then they're just executing that policy. So it gets you consistency. So the policy define how replication must be configured and how the system implements it, which makes sure every volume is configured correctly. And then it's hard to make mistakes because all the control is happening on the source. Simplicity, all remote provisioning is managed by the system. reducing the burden on storage admins or the opportunity to make mistakes. And then it's automated. So replication auto manages itself to adapt to conditions. So anybody who's done replication understands that there are going to be kind of peaks and valleys for when you push data across the wire. When you're assigning a policy, you're assigning a recovery point objective. That recovery point objective defines how you replicate, and it will actually go from um, like like a bursting model where it's using snapshots to burst data across, or it'll stay in almost like a metro mirror type environment where it's replicating data in real time. And it'll adjust on the fly based on the bandwidth and the amount of data that it needs to push across the wire. What's great about that, and great about them rewriting the whole back end replication, was the performance impact that we received from that rewrite. So if you look at like standard global mirror, which is in red, and global mirror is kind of the older school SAN-to-SAN replication technology with policy-based replication. You'll see the gray line there. We're seeing almost a 5x increase in performance across the wire for replication following the policy-based replication release. So that means you're going to be able to replicate with less bandwidth. You're also going to be able to ensure that your recovery point is much better than what you could have expected previously with like a global mirror environment. So another cool feature within IBM storage portfolio is called flash copy. So when I first started getting into all this and really driving folks to external storage, the number one reason that people would go to external storage was because of encryption, so compliance requirements. The second was flash copy. So what flash copy does is it creates a point in time copy or snapshot of an environment, so say a production environment, and it goes through a process where it pauses user access for a few seconds, and it creates a consistency group or a bitmap on both machines to track any changes. So with a flash copy, we've got our main partition, and then we would have a second partition that's sitting alongside of it, so completely different environment. Then we have a controlling partition. The controlling partition kind of plays quarterback and kicks everything off. But what you can do with that is you can take a copy of your production environment, create a flash copy. So on a second partition, you're not actually saving all that data or copying that data to that second partition. All it's doing is looking at the main partition, and anything that gets physically written to the main partition, the previous record or gets written to the flash copy partition to maintain that point in time consistency. And then what we would do on that flash copy partition, we would kick off a point in time backup. So you could do a full system save of your environment with an impact to users of say 10 to 30 seconds. And you can do that every night. So people who are challenged or we're having challenges with their backup windows, which in today's world, most businesses are running 24/7, 365. Flash copy allowed them to go from having to take an outage on, on a Sunday night and finally get like a full save 21 to being able to do a full save 21 every night. So typical use cases are to back up data. There's also some use cases that we've done where you're using that flash copy partition for testing, development, analytics. So there are lots of use cases for it, but most companies take advantage of it for doing their backups and reducing that backup window. So one of the cool tools that Expert Labs has is called the Flash Copy Toolkit. It allows you to have some flexible management um, of that environment and your backups. There's also a lot of integration that came into Flash Copy Snapshots with BRMS. So if you're a BRMS shop, it can actually create your BRMS recovery report so it looks like it backed up from your production partition, even though it's on a separate partition. So a lot of cool features that they're building into the tooling for BRMS in the toolkit for Expert Labs and Flash Copy. So taking Flash Copy a little bit further, IBM created a safeguard copy, which is a big differentiator at the storage level. Safeguard copy is a protection mechanism for data. So when we look at data, if you're replicating data across the wire or from machine to machine, if something gets corrupted or if something happens in your source side, it's going to be replicated over to the target side. So, so what Safeguard Copy does, it uses basically the snapshot functionality that we get for Flash Copy, and it has this completely immutable backup space on your SAN storage. So those backup copies are walled off from kind of the standard environment, and you can set up the safeguarded copy policy so that it does a snapshot every 2 hours, and it puts it in this immutable backup repository. So in order to get to those immutable backups, you set up a rule where maybe two people within your company have to put in a piece of information to be able to access it. And this gives you the ability to have those safe copies that are happening every couple hours to recover from in the event that something bad happens on your machine. So what's required for Safeguard Copy? You have to have flash some external storage. You also have to have some additional storage capacity to support Safeguard copies. There's a tool that they can use to configure a machine so that it supports, so that it can support the additional storage that you would need. With FlashPro modules, though, with the compression that you're able to get, and just the raw size of those individual modules, it tends to not be a huge issue to add enough storage to be able to support, a policy that has repetitive safeguard copies. You have to have a flash copy license, which most flash systems now come with automatically. And then there's automation scheduling process that has to get written. And then you have to define your additional security measures to prevent other people from accessing those safeguard copies. So great technology to allow yourself some additional resiliency. The next thing, so I'm kind of taking it maybe a step further because it all leans on similar technology, which is those snapshots, but it's ransomware threat detection. So IBM has developed tooling in a couple different ways. So there's software-based ransomware threat detection and there's hardware-based ransomware threat detection. So the hardware-based ransomware threat detection, that is something that you need the FlashCore modules for. So either FlashCore module 4s or FlashCore module 5s. In the entry point for those FlashCore modules in the Flash system 5600. But if you have a 5015 or 5045 and you want to take advantage of that software-based ransomware threat detection, you can still do that. It does put a strain on the control enclosure for the SAN storage. basically what it does, and it's not a so ransomware threat detection isn't a preventative type of solution. It's it's more of a response type of solution. So all businesses deal with cyber attacks. It's kind of inevitable in this day and age. So when you have a cyber attack, say like a ransomware attack, once that attack happens, the speed at which you're able to get back on your feet is critical. So if you don't have technology to kickstart the process of recovery, and put yourself in a position where you can recover without having to buy a bunch of Bitcoin and pay off a ransom, you need to have uh, you need to know about the ransomware threat very, very early on. So in the typical ransomware event, attack happens, you might not know about that attack for hours, weeks, months. With the ransomware threat detection that's on IBM Flash systems, you greatly reduce your ability to get back up on your feet again. So when you have ransomware threat detection, you also have um, safeguard copy. It's going to detect it's going to detect the ransomware very, very early on. We're talking minutes, and how it does that. It knows what your typical workload looks like on your FlashFlow modules, or at the controller level, it's monitoring for things that don't look normal. And then IBM's also constantly, injecting, different things that they've seen that uh, would reflect what a ransomware attack looks like. So in the previous, you look at the previous situation, they're not getting back on their feet for a couple weeks. When you have ransomware threat detection, you're able to get back up on your feet within hours. I mean, you're able to know about that ransomware attack much, much earlier on. Yeah, and this gives you kind of an example of the software implementation. So when you're using the SAN controller, to detect ransomware versus the hardware implementation, you're going to get a slight increase with the hardware implementation because of the technology that lives on the flash computers. So the other thing that folks can take advantage of when they have IBM SAN storage is we have Storage Insights. So Storage Insights is the back end GUI interface for monitoring and managing your IBM storage. It can also monitor and manage third-party storage underneath it. So, but Storage Insights, it guides focus to what's important to the business, for the health of the environment, uh, yeah, the health of the SAN storage itself. It's included, so the base Storage Insights is included at no extra cost with the IBM storage. You can upgrade to Storage Insights Pro, which there are a lot of really good reasons to do that. But there's some AI driven advisory tools that are built into it. You can raise and manage support cases directly from Storage Insights, see capacity trends and use volume as well. So some of the big differences between Storage Insights, the base version, and Storage Insights Pro, is there's so with Storage Insights Pro, you're going to get monitoring, and you're going to have data available for up to 2 years. Where with the standard insights, you're only going to have data available to you for 24 hours. There's a lot more granular reporting that happens with the Pro version. Um, there's alerting that is predefined and can be customized. And then you need it for inline threat detection, so that ransomware alerting. And then as well as a safeguarded copy. So if you want to use those things, you have to have Storage Insights Pro. It really isn't a huge increase in cost as well for what you're able to get. And then in order to get Storage Insights Pro, there are a couple key ways to do that, which are important to understand. There's IBM Storage Insights, and then so Storage Insights Pro will come with an Expert Care Premium package with your SAN storage. Expert Care, just touched on that. There are a couple different versions of Expert Care. They're in the slide deck for you to use. And then, the other thing I want to touch on, I know we're at time here. If you have questions, I'll gladly jump in and answer them through email or even give you a call if you want to chat about them. But for most folks that are on existing internal storage, there tends to be a concern about the ability and the pain that it would take to move from internal storage to SAN storage. One of the beautiful things about IBMI is it knows where everything exists on disk. So basically what we do to move customers from internal storage to external storage is we attach the SAN storage to their existing power system. We allocate some LUNs, so some virtual drives, to the IBMI storage pool. And then we tell IBMI that we want to eventually remove the internal storage that it has in its pool. So it's going to look like it has way more storage than what it should. So we'll drain those internal storage drives and shift all of that storage onto the SAN storage. And then the only thing that we need to actually take an outage for is to move the load source over. Once we move the load source over, and that internal storage can be removed, and you're completely running on IBM SAN storage. And then, when you look at costs, which everything costs a significant amount more these days, when you decouple the storage and OS from the processor itself, when you move to a new power system, so if you're on SAN storage, you want to move to a new power system, it's plug and play. You're bringing the machine down, moving some fiber cables, bringing the machine up on the new power system. With SAN storage migrations, if you wanted to upgrade to a new SAN at a given point in time, we can migrate to the new SAN the same way we just did, move from internal storage to external storage, or IBM has transparent data movement, which will basically automate the process for you. So with that, I hope everybody enjoyed it. Let me know if you need any, or if you have any questions. And then I just want to thank you for attending and let you know that there is a 15-minute break now. Well, a 12-minute break because I talked too much. But we'll see you on the next session.